All right, let's take a look at the quotient of powers property. So this property says, you can use this property as long as you have a power, x to the m, divided by another power, x to the n, and those two powers have to have the same bases. So x is the base in this case, right? So this is kind of a shortcut to the answer. We can use the quotient of powers property, right? Quotient means divide. So if we are dividing powers with the same bases, we can use this shortcut. And the shortcut is we take our common base, x in this case, pass it along to our answer, and we subtract the exponents. And you must take the top exponent minus the bottom exponent. And that's a shortcut to the answer, right? So let's look at a few other cases of this. Let's look at an example with some real numbers, okay? Variable expressions anyhow. Let's say we got maybe c to the 15th power divided by, let's say, c to the 10th power, okay? So we can use the quotient of powers property here because we are dividing, here's the division, right? We are dividing, a fraction means divide. We are dividing powers that have the same bases. The base in this case is c. So we can use the shortcut. We can take the common base c and pass it along. And our answer, at least our simplified answer, is going to have 15 minus 10 as the exponent, which will be c to the power 5, right? And then if someone told us what c was at some point, we could go ahead and substitute that in. But as of right now, that's as far as we can go. We just have a variable expression answer. Let's try another one. How about if we had something even with some numbers in it? What if we had like 8, let's say, to the 6th power divided by, instead of using a fraction this time just to change it up a little bit, I'm going to use an actual division symbol, which means the same thing as a fraction, right? So 8 to the 6th power, let's say, divided by maybe 8 to the 2nd power, or we could say 8 squared. So in that case, again, we're dividing powers with the same bases, right? I always like to picture this as being a fraction. So those two would actually be the same. Those would be equivalent expressions. Me personally, I like seeing it written as a fraction, but either way, it's the same, right? The first number in the division problem always goes on top, and the second number in a division problem always goes on bottom, right? Not necessarily the bigger number. A lot of people think the bigger number always goes on top. Well, it's not always that way, right? The first number written in the division problem always goes on top. The second number always goes on bottom. So in any case, we got a power divided by a power with the same basis. So let's pass that base along to our answer, and we'll take top exponent minus bottom one. Or if it's written as this way, it would be first exponent minus second. So 6 minus 2, that's going to give us a 4. And there's our answer as a power form anyhow. We could go ahead and work 8 to the 4th power out if we wanted to write that answer in standard form. But for what we're doing right now, we'll just leave our answers as a power. Let's add a little bit more to this. What if we throw some coefficients in here? So what if we had maybe something like 10 t to the 12th power divided by maybe something like 5t to the, let's say, 9th power. Well, in this case, hopefully everybody understands that anytime you have a number sitting right next to a variable with nothing shown in between, in math, it's automatically assumed that that's a times sign. So I'm going to go ahead and show a dot there. Same thing here, times. So how I like to do these problems is I like to think about these as being individual fractions, right? So I like to kind of address that situation there, 10 over 5, right? 10 divided by 5 with that times sign in between. And then we also have the t to the 12th divided by t to the 9th. So what I like to do is I like to look at these as being two separate fractions multiplied together like that, right? Because if you multiply these two fractions back together, which is really easy, right? You just multiply tops and bottoms. When you're multiplying fractions, you don't need any common denominators or anything. So this would multiply back out to give you 10t to the 12th, right? Over 5t to the 9th. So if we just kind of split these apart, we can address each one of these separately. So we can go ahead and take 10 divided by 5, and that gives us 2. And then we still have our times in between. And here we have a power divided by a power with the same bases, so we can pass our common base along and take top exponent minus bottom exponent. And 12 minus 9 is going to give us a 3. So there's a good answer. I'm just going to clean that up a little bit, right? We don't need to show that times sign there. We can just scoot the 2 right next to the t cubed, and there is a good simplest form answer in power form. So there we go. We did a little practice with the quotient of powers property.